Welcome to this presentation of the DEx SysML Bridge, a tool that connects DOORS to Enterprise Architect and enables you to move requirements from DOORS into the Enterprise Architect and from Enterprise Architect back to DOORS. Before looking at the bridge, let's talk about the SysML language and how requirements are handled in the SysML language. As you probably know, SysML is a profile on the UML language that reduces some parts of the UML language and adds some extensions that are specific to systems engineering. What has been added is basically two things. One is the support for requirements, and the other one support for parametric models. What we will be interested in here is the support for requirements. A requirement in SysML is an extension to the class element, which makes it possible to add a requirement text and a requirement identity. By having requirements in the modeling tool, it makes it possible to connect these requirements to other modeling artifacts. In SysML, you can use the containment relation to decompose a requirement into its sub-requirements. In DOORS, this would correspond to putting requirements below other requirements in the DOORS hierarchy. Something you would probably not be doing. Instead, you would put related requirements into the same chapter. Requirements traceability is specified by means of a number of stereotype dependencies. The derived requirement dependency connects a requirement to its background requirement. This could be, for example, a stakeholder requirement, and this could be a system requirement that has been derived from the stakeholder requirement. Or a system requirement and a subsystem requirement derived from the system requirement. The copy relation is very similar. The only difference really is that the slave requirement must have the exact same text as the master requirement. There is also a trace relation with a slightly undefined meaning. Other model elements can also be connected to requirements. This is really why we want to have the requirements in the modeling tool. The satisfy relation specifies that the model element needs to satisfy a requirement. There is also the refined relation. A requirement can be refined by, for example, a use case or an activity diagram. It can also be the other way around, that the requirement is used in order to refine some other model element. Finally, there is a verify relation between the requirement and the test case, which verifies the requirement. Now we are ready to take a closer look at the SysML Bridge. This tool helps you maintain the traceability in your system model across the tool borders. It also makes it possible for you to use the best tool for the problem at hand. You would typically use DOORS for requirements and Enterprise Architect for architectural modeling. But still, you would like to have some kind of connection between your requirements and your modeling artifacts. And this is what this tool can do. It can synchronize your requirements and your traceability in both directions, from DOORS to Enterprise Architect or from Enterprise Architect to DOORS. There is also a conflict detection, which makes it possible for you to see if a change has been done on both sides. It's also very easy to navigate between the tools. If you are looking at the requirement in DOORS, you could easily find the corresponding requirement in the Enterprise Architect. Let's have a look at the usage example. In this example, we have a requirement in DOORS, a system requirement. This requirement is then transferred using the SysML Bridge into Enterprise Architect. Once it has been transferred, it means that you can synchronize changes in any of the two directions, from DOORS to Enterprise Architect or the other way around. It's also possible to navigate in both directions. So if you have selected a requirement in DOORS, you can easily find the corresponding requirement in Enterprise Architect and the other way around. Now when the requirement is also in the Enterprise Architect, you may use some modeling to derive new requirements for the next system level. In this case, an activity diagram is created that allocates responsibility really to two different subsystems, X and Y. And then, based on this activity diagram, you can create new requirements at the subsystem level for these two subsystems. These are refinements of the activity diagram, but they are also derived from the system requirement. So if you set up these derived requirement connections to the system requirement, it's possible to get that traceability back into DOORS. So what you can do now is that you can transfer these requirements into DOORS, like this. And you get the requirement, but you also get a traceability link corresponding to the derived requirement relation. And here is the other requirement. So you can see how you can do your requirements for specification both at the system level and at the subsystem level in DOORS. But you can also do your modeling, your requirement breakdown in the Enterprise Architect, and still maintain the traceability. Time now to see the SysML Bridge in action. In this demo, we have two DOORS modules, one system requirement spec that links to a stakeholder requirement spec. Let's see if we can find a link here. Here. Let's follow the link to get to the stakeholder requirements. In both these modules, there's an attribute called class that defines what is a requirement and what is not a requirement. Here is a requirement, for example. And same thing in the system requirement spec. And the mapping here has been set up. The mapping for transferring data between DOORS and Enterprise Architect has been set up to transfer all the objects that are tagged as requirements. But it will not transfer objects like this one that's tagged with info, for example. And let's start by transferring the stakeholder requirements. I have a running instance here of the Enterprise Architect. And what I do is that I create a package corresponding to the stakeholder requirement spec. FlexiBoat STRS. FlexiBoat. Like this. Another point that the structure I want to transfer, I start the SysML Bridge tool. And the first thing I need to do is to connect to Enterprise Architect. It connects to the running instance of Enterprise Architect. And here to the left you can see the current object in DOORS. It's the stakeholder requirements chapter. And on the right side, the current requirement in Enterprise Architect, which is the package I just created. Pressing transfer will transfer the stakeholder requirements as a new child to the FlexiBoat STRS in the Enterprise Architect. Let's do that. Sorry. I need to uncheck dry run. Dry run is for checking what will happen, but without doing any changes. So dry run. Now I do the transfer. And you can see that I get the same structure in Enterprise Architect that I had in DOORS. Also, when I select an object here in DOORS, the corresponding object gets selected in Enterprise Architect. That's because I have selected automatic navigation here. So that makes it very easy to navigate. But you can do it the other way around also. If I point to this one, for example, I want to have the same object in DOORS. Well, nothing happens until I press refresh, but then I get here to an automatic navigation to the same object in DOORS. What I didn't show was actually there's a log also. Here is the synchronization log that tells you what actually happened in the transfer we did. Created lots of objects and updated attributes. So you can hide the log or show the log as you like. Okay, now we have transferred the stakeholder requirements. Let's go on and transfer the system requirements. We can close this SysML Bridge and open the system requirements. And here I open another instance of the SysML Bridge, now in the context of this module. And what I want to do is to transfer the system requirements. Of course, I need to connect to the Enterprise Architect also. And here I want to have a new package for the FlexiBoat SCRS. I transfer the system requirements below that package. Let's have a look at the log. Yep. And the same thing here. If I select the requirement, the corresponding requirement gets selected in Enterprise Architect. So what we did was actually to transfer the requirements, but we also transferred the traceability. If I look here at the traceability, you can see that in DOORS, this requirement links to 3 different requirements in enterprise in the stakeholder requirements, number 4, 5, and 31. And you can see you have the same dependency here, 4, 5, and 31. I suggest we create a requirement diagram. And then we can move this requirement into the diagram when I want to see it in rectangle motion, and I want to see some more things here. Properties of the diagram. I want to see the tagged values. So here I can see my requirement with the ID and text. The main hull shall not be longer than 4.8 meters. But I also want to put these other requirements in the same diagram. Switch to related. Okay, here they are. 4, 5, and 31. And as you can see here, there is a derived requirement relation that actually comes from DOORS. Corresponds to the traceability links in DOORS. Let's use the rectangular notation instead. That's much nicer. So here you have a simple requirements diagram where you can see how this requirement is derived from 3 different system requirements. But of course, that's not the point here. I mean, the really interesting thing is when you start connecting these requirements to other modeling artifacts like activity diagrams. A mapping specification in each module defines how things are to be transferred or synchronized, how changes are to be synchronized. And this mapping is defined here. I press edit mapping and I can enter mapping specification with a simple text syntax. The first rule here says that the sync direction is both ways. Sync direction 2 would mean that the synchronization and the transfer is limited to transferring data from DOORS into Enterprise Architect. From means Enterprise Architect to DOORS. Next is a rule that states that a requirement in Enterprise Architect is matched by an object with class equals requirement, class equals rec in DOORS. Then comes a number of attribute mapping rules. It says that object text should be mapped in any direction to the tagged value text. The object identifier in DOORS should be mapped onto attribute name. Also, next one, it should be mapped onto tagged value ID. The object identifier in DOORS is read-only, so it can only be in the direction from DOORS to Enterprise Architect. Then comes a similar specification of what constitutes a package. Any object in DOORS that has a non-empty object heading will be mapped onto a package. And similarly, there are a number of attribute mappings for packages. The object heading, for example, will go into the name attribute. That's why you can see the name here. There's also a heading number, a tag value that contains the object number from DOORS. Let's have a look here at the tag values. Yeah, 2.4 in DOORS. Motoring 2.4. And if there is an object text, it gets into notes, but you should normally not have an object text for a heading. So perhaps we should actually remove this last line, but never mind. So this is the mapping that controls what to be transferred. Now let's do some changes and see what happens. Let's say we want to change this requirement. It should be 5.2 meters. And when you look here in the SysML Bridge, you can see there's a green arrow here. It says that this has been updated since the last synchronization. Does not really match the Enterprise Architect requirement. So it needs to be synchronized from DOORS to Enterprise Architect. If you do a similar change here in Enterprise Architects, says a conflicting change like this. You see, now you have red arrows that tell you there's a conflict here. It has been changed on both sides since the last synchronization. So this means that you will lose data when you synchronize the changes, regardless of which direction you synchronize. So you need to really solve this before you synchronize. If you want to see what conflicts you have, one way of doing this is to do a dry run. Let's select system requirements and do a complete dry run. And we unselect verbose logging, so we won't only see the conflicts. And we try a synchronization from DOORS to Enterprise Architect. Let's see what's in the log. Let's clear the log first. Now we try to synchronize. And here you can see this conflict. So if we do the actual synchronization, this requirement will be updated to 5.2 meters here. So the change in the Enterprise Architect will be overwritten. If you don't want that, you need to manually merge the data. Now let's create a new requirement in the Enterprise Architect and synchronize that into DOORS. Below transporting, we could then say add element. It should be SysML 1.3. requirement. And let's call it width. And we enter the main hull shall not be wider than 1.9 meters. Okay. We dragged this into the diagram here. And now let's create a traceability. It's say that this is derived from this stakeholder requirement number 4. To be able to transport it on a car, it mustn't be too wide. Okay. Now let's go back to DOORS, and we select system requirements here. We could select the transporting chapter if we like also, if we only synchronize that one, but let's synchronize everything. So I synchronize in direction from Enterprise Architect to DOORS. Ah, right. This is the way it should be. Synchronize. And now let's have a look at transporting. Refresh. Ah, sorry. I put it in the wrong place. I should have put it in the nothing actually happened because we didn't synchronize that structure. What we did was this should have been below the system requirement spec. Below hull over here. Let's put the new requirement there instead. And now we could synchronize. Synchronize from Enterprise Architect to DOORS. And now you should be able to see this. Yeah, the main hull shall not be wider than 1.9 meters. And it also has a requirement link to this stakeholder requirement number 4. Note that this requirement in Enterprise Architect actually got a different identity. The name was changed from width to SURS73, as you can see here. And also the ID was set to the same. And that's because the mapping says so. The object identifier should go into the attribute name and to the tag value ID. So this actually meant that although the synchronization was from Enterprise Architect to DOORS, these specific values went in the opposite direction. Now let's delete the requirement and see what happens. If I press show module here, the module gets promoted to the top here. Let's select a requirement like, yeah, we don't need a master any longer. Let's remove this one. Delete it in DOORS. And let's just synchronize this chapter, sailor equipment. And you can see what happened here is that a basket package was created, and this SURS19 is moved over there. So it's not actually deleted. That's something you need to do yourself if you don't need it any longer. So you could delete the wastebasket and all its contents. And let's say you delete a requirement in Enterprise Architect. Now we synchronize this chapter in the other direction. And then number 21 was deleted. Let's have a look. View, show, deletions. Yeah, here they are, the two delete requirements. Now let's do some changes to links and see how that is indicated in the SysML bridge. This one, for example. Let's look at the properties. It has an outgoing link to number 14. Let's delete that one. Let's create another link to yeah, doesn't matter really, to this one. Make link from start. Now if you look at, sorry, let's clear start. Now if you look here, you can see that the links, changes of links you have done in DOORS, they need to be synchronized to Enterprise Architect. There's one new and one deleted link here. And one existing link on the Enterprise Architect side that has not been changed since the last synchronization. So if we could, of course, synchronize those changes into Enterprise Architect. Let's see what happens if we synchronize in the other direction. Yeah, we could synchronize this single requirement only if we like. So interesting. Let's see what happened. Yeah, we have the initial situation. The changes in DOORS were overwritten by the state that was already there in Enterprise Architect. So the changes were undone, you could say. Please note that the mapping state is saved in the DOORS module. So you should actually be careful to always save the DOORS module, which I should have done a long time ago. Let's save both these modules. And let's close this and have a look at the attributes that control this. We have already looked at this module attribute, the map spec, which contains the mapping specification. But there are also a number of object attributes. The most important one is the EAGWID. This is the actual connection between DOORS and Enterprise Architect. It says that this requirement or this package has a corresponding object in Enterprise Architect with this unique identifier. There are also a couple of attributes that have to do with the the state of the last synchronization that's needed in order to detect the conflicts. We have the last sync values. Where all the mapped attributes are actually saved in a special syntax. And we have the last sync links. The list of the list of target objects in the form of GID. This one, for example, links to two stakeholder requirements, and these are the GUIDs of these two. So both these two last attributes have to do with detecting changes since the last synchronization. And that's about what I was going to show you in this presentation. So this concludes the presentation, and I hope you have enjoyed spending this time. Thank you.